Hello, let's solve this question. A body, a body of mass m falls from rest at a height h under acceleration due to gravity. Right? Through a dense medium, which provides a resistive force. Let's assume as Fr as minus k v square, right? Where k is constant and v is the speed, and v is the speed, right? Then we need to find the kinetic energy with which body hits the ground. So we need to find the kinetic energy, right? So let's find out the velocity first. So a body of mass m falls from a height h. So let's assume that a body of mass m. So let's assume this as a ground. And let's consider the highest position as x equal to 0. And when it reaches this point, it is x equal to h. I mean, you are considering this as a positive direction, right? When the body is at an arbitrary distance from the ground, so let's say this at this height m, this body m, what are the forces acting on it? There will be gravitational force Fg, and there is a resistive force because of the dense medium, which is Fr, right? According to Newton's second law, net force, right? F net external force acting on a body is mass times acceleration. As the body is moving in the downward direction, I mean, which is the positive in our case here, which is mg minus k v square, right, is m into a. As we need to figure out the velocity, because ultimately we need to figure out the kinetic energy, a can be written as dv by dt, which you can write it as dv by dx into dx by dt, which is this dx by dt is v, and this dv by dx. So then this equation becomes mg minus kv square equal to m into v into dv by dx, right? So let's do some calculations here. Simplification. If you take m as common here, then this will be m into g minus kv square equal to mv dv by dx, right? Then this will be, sorry, here it's k by m, right? There is no m here. Then m will get cancelled. So as you can see, there is a function of v here. So v by g minus kv square by m dv is dx. Right? Then we need to integrate these cases from x equal to 0 to h, and from the top the velocity is 0 to final velocity when it hits the ground. So let's consider some substitutions here. Let's consider g minus k by m v square equal to y. Then this will be minus k by m, 2v into dv is dy, then v dv is minus m by minus m by 2k dy. So this will be integral. What is v here? V dv is minus m by 2k dy. Here g minus kv square by m is y. Alright, here then let's substitute this integral limits as it is. Then we can, after integrating, we can substitute the y in terms of v. Then we can apply the limits, which is integral. This will be integral dx is h. Then it will be h minus 0, which will be h. Fine. Then this is as minus m by 2k is constant, keep it out of the integral. Then we are left with 1 by y dy. Integral limits are 0 to vf, which is h. Then this will be minus m by 2k into 1 by y is ln y. Integral limits 0 to vf equal to h. So let's write what is y first. Ln of, here y is g minus k by m v square. G minus k by m v square. The integration limits are 0 to vf, then which is equal to h. Then this is minus m by 2k ln of g minus k by m vf square. Then when you substitute 0, k by m v square will be 0. Then we are left with g is equal to h. Let's make it more simplified version. Then this will be ln of 1 minus k by mg vf square equal to minus 2kh by m, which can be written as 1 minus k by mg vf square equal to e power minus 2kh by m. Fine. Then this will be 1 minus e power minus 2kh by m equal to k by mg vf square. So finally vf square equal to mg by k into 1 minus e power minus 2kh by m. Right? The final velocity when it hits the ground. Now the kinetic energy is half m v f square, which is half m square g by k into 1 minus e power minus 2kh by m. So this is the solution.